We have to remember that if the form is not in the infinity over infinity form or 0 over 0 form, we need to convert it into that form. So this example, we have infinity times 0. So this is, if we plug it in, so let's plug it in here. So we get log of 0 from the positive side. That's going to be negative infinity. And again, if we want to look at what that looks like, we have a log function going to negative infinity, and sine of 0 is 0. So this is one of the indeterminate forms, but we have to convert it into a ratio of infinity over infinity or 0 over 0. So this is fairly easy to do. We just put one of these in the denominator, whatever one's going to be a little bit easier. So I'm going to put the sine into the denominator. So I'm going to write this as log x over cosecant x. Okay, so I can now differentiate, I can now evaluate this. Plugging in, I get negative infinity, and as 0 cosecant goes to 0 from the positive side, it's going to approach positive infinity. Okay, so there's our condition that we need to apply L'Hopital's. So we're going to apply L'Hopital's to this expression. Okay, applying L'Hopital's, we're going to differentiate the top and the bottom independently. So we get 1 over x over the derivative of cosecant is negative cosecant x cotan x. So when we do this, now because these are all reciprocals, we're going to put this into a little bit easier form to work with. So we're going to put this negative up top, and we'll write this as sine x tan x in the numerator, and we'll put the x in the denominator. And when we apply this, now we end up with 0 over 0. So we haven't resolved this yet. However, we again generated the condition that we need to apply L'Hopital's. So we'll do that one more time. So we'll apply L'Hopital's and see what we get. Okay, so applying L'Hopital's again, we're going to end up with the derivative of that. So we're going to have to use product rule. So we're going to end up with cos x tan x plus, and I factor that negative out, sine x, and then secant squared x. That's the numerator. The denominator just becomes 1. And now we try to evaluate this limit again. So evaluating this limit, we get negative on top. So this is going to be cosine of 0 is 1. So I'm just going to put square brackets around this to differentiate this. So we have tan of 0 is 0 plus sine of 0 is 0. Secant squared of 0 is 1. And that's all over 1. So this limit ends up at 0. Okay, so the limit of that original expression, the limit as x approaches 0 from the positive side of log x sine x is equal to 0.